Petroleum, or crude oil, is a fossil fuel and non-renewable source of energy. Like coal and natural gas, petroleum was formed from the remains of ancient marine organisms, such as plants, algae, and bacteria. Over millions of years of intense heat and pressure, these organic remains fossils transformed into carbon-rich substances we rely on as raw materials for fuel and a wide variety of products. Millions of years ago, algae and plants lived in shallow seas. After dying and sinking to the seafloor, the organic material mixed with other sediments and was buried. Over millions of years under high pressure and high temperature, the remains of these organisms transformed into what we know today as fossil fuels. Coal, natural gas and petroleum are all fossil fuels that formed under similar conditions. Today, petroleum is found in vast underground reservoirs where ancient seas were located. Petroleum reservoirs can be found beneath land or the ocean floor. Their crude oil is extracted with giant drilling machines. Crude oil is usually black or dark brown, but can also be yellowish, reddish, tan or even greenish. Variations in color indicate the distinct chemical compositions of different supplies of crude oil. Petroleum that has few metals or sulfur, for instance, tends to be lighter, sometimes nearly clear. Petroleum is used to make gasoline, an important product in our everyday lives. It is also processed and part of thousands of different items, including tires, refrigerators, life jackets and anesthetics. When petroleum products such as gasoline are burned for energy, they release toxic gases and high amounts of carbon dioxide, a greenhouse gas. Carbon helps regulate Earth's atmospheric temperature, and adding to the natural balance by burning fossil fuels adversely affects our climate. There are huge quantities of petroleum found under Earth's surface and in tar pits that bubble to the surface. Petroleum even exists far below the deepest wells that are developed to extract it. However, petroleum, like coal and natural gas, is a non-renewable source of energy. It took millions of years for it to form, and when it is extracted and consumed, there is no way for us to replace it. Oil supplies will run out. Eventually, the world will reach peak oil, or its highest production level. Some experts predict peak oil could come as soon as 2050. Finding alternatives to petroleum is crucial to global energy use, and is the focus of many industries. Formation of petroleum. The geological conditions that would eventually create petroleum formed millions of years ago, when plants, algae and plankton drifted in oceans and shallow seas. These organisms sank to the seafloor at the end of their life cycle. Over time, they were buried and crushed under millions of tons of sediment and even more layers of plant debris. Eventually, ancient seas dried up and dry basins remained, called sedimentary basins. Deep under the basin floor, the organic material was compressed between Earth's mantle, with very high temperatures, and millions of tons of rock and sediment above. Oxygen was almost completely absent in these conditions, and the organic matter began to transform into a waxy substance called kerogen. With more heat, time and pressure, the kerogen underwent a process called catagenesis, and transformed into hydrocarbons. Hydrocarbons are simply chemicals made up of hydrogen and carbon. Different combinations of heat and pressure can create different forms of hydrocarbons. Some other examples are coal, peat and natural gas. Sedimentary basins, where ancient seabeds used to lie, are key sources of petroleum. In Africa, the Niger Delta Sedimentary Basin covers land in Nigeria, Cameroon and Equatorial Guinea. More than 500 oil deposits have been discovered in the massive Niger Delta Basin, and they comprise one of the most productive oil fields in Africa. Chemistry and classification of crude oil. The gasoline we use to fuel our cars, the synthetic fabrics of our backpacks and shoes, and the thousands of different useful products made from petroleum come in forms that are consistent and reliable. However, the crude oil from which these items are produced is neither consistent nor uniform. Crude oil is composed of hydrocarbons, which are mainly hydrogen, about 13% by weight, and carbon, about 85%. Other elements such as nitrogen, about 0.5%, sulfur, 0.5%, oxygen, 1%, and metals such as iron, nickel, and copper, less than 0.1%, can also be mixed in with the hydrocarbons in small amounts. The way molecules are organized in the hydrocarbon is a result of the original composition of the algae, plants or plankton from millions of years ago. The amount of heat and pressure the plants were exposed to also contributes to variations that are found in hydrocarbons and crude oil. Due to this variation, crude oil that is pumped from the ground can consist of hundreds of different petroleum compounds. Light oils can contain up to 97% hydrocarbons, while heavier oils and bitumens might contain only 50% hydrocarbons and larger quantities of other elements. It is almost always necessary to refine crude oil in order to make useful products. Oil is classified according to three main categories: the geographic location where it was drilled, its sulfur content, and its API gravity, a measure of density. Oil is drilled all over the world. However, there are three primary sources of crude oil that set reference points for ranking and pricing other oil supplies: Brent crude, West Texas Intermediate, and Dubai and Oman. Brent crude is a mixture that comes from 15 different oil fields between Scotland and Norway in the North Sea. These fields supply oil to most of Europe. West Texas Intermediate WTI is a lighter oil that is produced mostly in the U.S. state of Texas. It is sweet and light, considered very high quality. WTI supplies much of North America with oil. Dubai crude, also known as Fateh or Dubai Oman crude, is a light, sour oil that is produced in Dubai, part of the United Arab Emirates. The nearby country of Oman has recently begun producing oil. Dubai and Oman crudes are used as a reference point for pricing Persian Gulf oils that are mostly exported to Asia. The OPEC reference basket is another important oil source. OPEC is the Organization of Petroleum Exporting Countries. The OPEC reference basket is the average price of petroleum from OPEC's 12 member countries: Algeria, Angola, Ecuador, Iran, Iraq, Kuwait, Libya, Nigeria, Qatar, Saudi Arabia, the United Arab Emirates, and Venezuela. Sulfur is considered an impurity in petroleum. Sulfur in crude oil can corrode metal in the refining process and contribute to air pollution. Petroleum with more than 0.5% sulfur is called sour, while petroleum with less than 0.5% sulfur is sweet. Sweet oil is usually much more valuable than sour because it does not require as much refining and is less harmful to the environment. The American Petroleum Institute (API) is a trade association for businesses in the oil and natural gas industries. The API has established accepted systems of standards for a variety of oil and gas-related products, such as gauges, pumps, and drilling machinery. The API has also established several units of measurement. The API unit, for instance, measures gamma radiation in a borehole, a shaft drilled into the ground. API gravity is a measure of the density of petroleum liquid compared to water. If a petroleum liquid's API gravity is greater than 10, it is light and floats on top of water. If the API gravity is less than 10, it is heavy and sinks in water. Light oils are preferred because they have a higher yield of hydrocarbons. Heavier oils have greater concentrations of metals and sulfur, and require more refining. Petroleum is found in underground pockets called reservoirs. Deep beneath the earth, pressure is extremely high. Petroleum slowly seeps out toward the surface, where there is lower pressure. It continues this movement from high to low pressure until it encounters a layer of rock that is impermeable. The petroleum then collects in reservoirs, which can be several hundred meters below the surface of Earth. Petroleum can be contained by structural traps, which are formed when massive layers of rock are bent or faulted broken from Earth's shifting land masses. Oil can also be contained by stratigraphic traps. Different strata, or layers of rock, can have different amounts of porosity. Crude oil migrates easily through a layer of sandstone, for instance, but would be trapped beneath a layer of shale. Geologists, chemists, and engineers look for geological structures that typically trap petroleum. They use a process called seismic reflection to locate underground rock structures that might have trapped crude oil. During the process, a small explosion is set off. Sound waves travel underground, bounce off of the different types of rock, and return to the surface. Sensors on the ground interpret the returning sound waves to determine the underground geological layout and possibility of a petroleum reservoir. The amount of petroleum in a reservoir is measured in barrels or tons. An oil barrel is about 42 gallons. This measurement is usually used by oil producers in the United States. Oil producers in Europe and Asia tend to measure in metric tons. There are about 6 to 8 barrels of oil in a metric ton. The conversion is imprecise because different varieties of oil weigh different amounts, depending on the amount of impurities. Crude oil is frequently found in reservoirs along with natural gas. In the past, natural gas was either burned or allowed to escape into the atmosphere. Now, technology has been developed to capture the natural gas and either re-inject it into the well or compress it into liquid natural gas (LNG). LNG is easily transportable and has versatile uses. Extracting petroleum. In some places, petroleum bubbles to the surface of Earth. In parts of Saudi Arabia and Iraq, for instance, porous rock allows oil to seep to the surface in small ponds. However, most oil is trapped in underground oil reservoirs. The total amount of petroleum in a reservoir is called oil in place. Many petroleum liquids that make up a reservoir's oil in place are unable to be extracted. These petroleum liquids may be too difficult, dangerous, or expensive to drill. The part of a reservoir's oil in place that can be extracted and refined is that reservoir's oil reserves. The decision to invest in complex drilling operations is often made based on a site's proven oil reserves. Drilling can either be developmental, exploratory, or directional. Drilling in an area where oil reserves have already been found is called developmental drilling. Prudhoe Bay, Alaska, United States, has the largest oil reserves in the United States. Developmental drilling in Prudhoe Bay includes new wells and expanding extraction technology. Drilling where there are no known reserves is called exploratory drilling. Exploratory, also called wildcat drilling, is a risky business with a very high failure rate. However, the potential rewards of striking oil tempt many wildcatters to attempt exploratory drilling. Diamond Glenn McCarthy, for example, is known as the king of the wildcatters because of his success in discovering the massive oil reserves near Houston, Texas, United States. McCarthy struck oil 38 times in the 1930s, earning millions of dollars. Directional drilling involves drilling vertically to a known source of oil, then veering the drill bit at an angle to access additional resources. Accusations of directional drilling led to the first Gulf War in 1991. Iraq accused Kuwait of using directional drilling techniques to extract oil from Iraqi oil reservoirs near the Kuwaiti border. Iraq subsequently invaded Kuwait, an act which drew international attention and intervention. After the war, the border between Iraq and Kuwait was redrawn, with the reservoirs now belonging to Kuwait. On land, oil can be drilled with an apparatus called an oil rig or drilling rig. Offshore, oil is drilled from an oil platform. Most modern wells use an air rotary drilling rig, which can operate 24 hours a day. In this process, engines power a drill bit. A drill bit is a cutting tool used to create a circular hole. The drill bits used in air rotary drilling rigs are hollow steel, with tungsten rods used to cut the rock. Petroleum drill bits can be 36 centimeters, 14 inches in diameter. As the drill bit rotates and cuts through the earth, small pieces of rock are chipped off. A powerful flow of air is pumped down the center of the hollow drill, and comes out through the bottom of the drill bit. The air then rushes back toward the surface, carrying with it tiny chunks of rock. Geologists on site can study these pieces of pulverized rock to determine the different rock strata the drill encounters. When the drill hits oil, some of the oil naturally rises from the ground, moving from an area of high pressure to low pressure. This immediate release of oil can be a gusher, shooting dozens of meters into the air, one of the most dramatic extraction activities. It is also one of the most dangerous, and a piece of equipment called a blowout preventer redistributes pressure to stop such a gusher. Pumps are used to extract oil. Most oil rigs have two sets of pumps, mud pumps and extraction pumps. Mud is the drilling fluid used to create boreholes for extracting oil and natural gas. Mud pumps circulate drilling fluid. The petroleum industry uses a wide variety of extraction pumps. Which pump to use depends on the geography, quality, and position of the oil reservoir. Submersible pumps, for example, are submerged directly into the fluid. A gas pump, also called a bubble pump, uses compressed air to force the petroleum to the surface or well. One of the most familiar types of extraction pumps is the pump jack, the upper part of a piston pump. Pump jacks are nicknamed thirsty birds, or nodding donkeys, for their controlled, regular dipping motion. A crank moves the large, hammer-shaped pump jack up and down. Far below the surface, the motion of the pump jack moves a hollow piston up and down, constantly carrying petroleum back to the surface or well. Successful drilling sites can produce oil for about 30 years, although some produce for many more decades. Even after pumping, the vast majority, up to 90%, of the oil can remain tightly trapped in the underground reservoir. Other methods are necessary to extract this petroleum, a process called secondary recovery. Vacuuming the extra oil out was a method used in the 1800s and early 20th century, but it captured only thinner oil components and left behind great stores of heavy oil. Water flooding was discovered by accident. In the 1870s, oil producers in Pennsylvania noticed that abandoned oil wells were accumulating rainwater and groundwater. The weight of the water in the boreholes forced oil out of the reservoirs and into nearby wells, increasing their production. Oil producers soon began intentionally flooding wells as a way to extract more oil. The most prevalent secondary recovery method today is gas drive. During this process, a well is intentionally drilled deeper than the oil reservoir. The deeper well hits a natural gas reservoir, and the high-pressure gas rises, forcing the oil out of its reservoir. Drilling offshore is much more expensive than drilling onshore. It usually uses the same drilling techniques as onshore, but requires a massive structure that can sustain the tremendous strength of ocean waves in stormy seas. Offshore drilling platforms are some of the largest man-made structures in the world. They often include housing accommodations for people who work on the platform, as well as docking facilities and a helicopter landing pad to transport workers. The platform can either be tethered to the ocean floor and float, or can be a rigid structure that is fixed to the bottom of the ocean, sea, or lake with concrete or steel legs. The Hibernia platform, 315 kilometers, 196 miles, off Canada's eastern shore in the North Atlantic, is one of the world's largest oil platforms. More than 70 people work on the platform, in 3-week shifts. The platform is 111 meters, 364 feet, tall and is anchored to the ocean floor. About 450,000 tons of solid ballast were added to give it additional stability. The platform can store up to 1.3 million barrels of oil. In total, Hibernia weighs 1.2 million tons. However, the platform is still vulnerable to the crushing weight and strength of icebergs. Its edges are serrated and sharp to withstand the impact of sea ice or icebergs. Oil platforms can cause enormous environmental disasters. Problems with the drilling equipment can cause the oil to explode out of the well and into the ocean. Repairing the well hundreds of meters below the ocean is extremely difficult, expensive, and slow. Millions of barrels of oil can spill into the ocean before the well is plugged. When oil spills in the ocean, it floats on the water and wreaks havoc on the animal population. One of its most devastating effects is on birds. Oil destroys the waterproofing abilities of feathers, and birds are not insulated against the cold ocean water. Thousands can die of hypothermia. Fish and marine mammals, too, are threatened by oil spills. The dark shadows cast by oil spills can look like food. Oil can damage animals' internal organs and be even more toxic to animals higher up in the food chain, a process called bioaccumulation. A massive oil platform in the Gulf of Mexico, the Deepwater Horizon, exploded in 2010. This was the largest accidental marine oil spill in history. 11 platform workers died, and more than 4 million barrels of oil gushed into the Gulf of Mexico. More than 40,000 barrels flowed into the ocean every day. 8 national parks were threatened. The economies of communities along the Gulf Coast were threatened as the tourism and fishing industries declined, and more than 6,000 animals died. Offshore oil platforms can also act as artificial reefs. They provide a surfaced substrate for algae, coral, oysters, and barnacles. This artificial reef can attract fish and marine mammals, and create a thriving ecosystem. Until the 1980s, oil platforms were deconstructed and removed from the oceans, and the metal was sold as scrap. In 1986, the National Marine Fisheries Association developed the Rigs to Reefs program. Now, oil platforms are either toppled by underwater explosion, removed and towed to a new location, or partially deconstructed. This allows the marine life to continue flourishing on the artificial reef that had provided habitats for decades. The environmental impact of the Rigs to Reefs program is still being studied. Oil platforms left underwater can pose dangers to ships and divers. Fishing boats have had their nets caught in the platforms, and there are concerns about safety regulations of the abandoned structures. Environmentalists argue that oil companies should be held accountable to the commitment they originally agreed upon, which was to restore the seabed to its original condition. By leaving the platforms in the ocean, oil companies are excused from fulfilling this agreement, and there is concern this could set a precedent for other companies that want to dispose of their metal or machinery in the oceans. Crude oil does not always have to be extracted through deep drilling. If it does not encounter rocky obstacles underground, it can seep all the way to the surface and bubble above ground. Bitumen is a form of petroleum that is black, extremely sticky, and sometimes rises to Earth's surface. In its natural state, bitumen is typically mixed with oil sands, or tar sands, which makes it extremely difficult to extract in an unconventional source of oil. Only about 20% of the world's reserves of bitumen are above ground and can be surface mined. Unfortunately, because bitumen contains high amounts of sulfur and heavy metals, extracting and refining it is both costly and harmful to the environment. Producing bitumen into useful products releases 12% more carbon emissions than processing conventional oil. Bitumen is about the consistency of cold molasses, and powerful hot steam has to be pumped into the well in order to melt the bitumen to extract it. Large quantities of water are then used to separate the bitumen from sand and clay. This process depletes nearby water supplies. Releasing the treated water back into the environment can further contaminate the remaining water supply. Processing bitumen from tar sands is also a complex, expensive procedure. It takes 2 tons of oil sands to produce 1 barrel of oil. However, we depend on bitumen for its unique properties. About 85% of the bitumen extracted is used to make asphalt to pave and patch our roads. A small percentage is used for roofing and other products. Most of the world's tar sands are in the eastern part of Alberta, Canada, in the Athabasca oil sands. Other major reserves are in the North Caspian Basin of Kazakhstan and Siberia, Russia. The Athabasca oil sands are the 4th largest reserves of oil in the world. Unfortunately, the bitumen reserves are located beneath part of the boreal forest, also called the taiga. This makes extraction both difficult and environmentally dangerous. The taiga circles the northern hemisphere just below the frozen tundra, spanning more than 5 million square kilometers, 2 million square miles, mostly in Canada, Russia, and Scandinavia. It accounts for almost 1/3 of all of the forested land on the planet. The taiga is sometimes called the lungs of the planet, because it filters tons of water and oxygen through the leaves and needles of its trees every day. Every spring, the boreal forest releases immense amounts of oxygen into the atmosphere and keeps our air clean. It is home to a mosaic of plant and animal life, all of which depend on the mature trees, mosses, and lichen of the boreal biome. Surface mines are estimated to only take up 0.2% of Canada's boreal forest. About 80% of Canada's oil sands can be accessed through drilling, and 20% by surface mining. Refining petroleum is the process of converting crude oil or bitumen into more useful products, such as fuel or asphalt. Crude oil comes out of the ground with impurities, from sulfur to sand. These components have to be separated. This is done by heating the crude oil in a distillation tower that has trays and temperatures set at different levels. Oils, hydrocarbons, and metals have different boiling temperatures, and when the oil is heated, vapors from the different elements rise to different levels of the tower before condensing back into a liquid on the tiered trays. Propane, kerosene, and other components condense on different tiers of the tower, and can be individually collected. They are transported by pipeline, ocean vessels, and trucks to different locations, to either be used directly or further processed. Oil was not always extracted, refined, and used by millions of people as it is today. However, it has always been an important part of many cultures. The earliest known oil wells were drilled in China as early as 350 CE. The wells were drilled almost 244 meters, 800 feet deep using strong bamboo bits. The oil was extracted and transported through bamboo pipelines. It was burned as a heating fuel and industrial component. Chinese engineers burned petroleum to evaporate brine and produce salt. On the west coast of North America, indigenous people used bitumen as an adhesive to make canoes and baskets watertight, and as a binder for creating ceremonial decorations and tools. By the 7th century, Japanese engineers discovered that petroleum could be burned for light. Oil was later distilled into kerosene by a Persian alchemist in the 9th century. During the 1800s, petroleum slowly replaced whale oil in kerosene lamps, producing a radical decline in whale hunting. The modern oil industry was established in the 1850s. The first well was drilled in Poland in 1853, and the technology spread to other countries and was improved. The Industrial Revolution created a vast new opportunity for the use of petroleum. Machinery powered by steam engines quickly became too slow, small-scale, and expensive. Petroleum-based fuel was in demand. The invention of the mass-produced automobile in the early 20th century further increased demand for petroleum. Petroleum production has rapidly increased. In 1859, the U.S. produced 2,000 barrels of oil. By 1906, that number was 126 million barrels per year. Today, the U.S. produces about 6.8 billion barrels of oil every year. According to OPEC, more than 70 million barrels are produced worldwide every day. That is almost 49,000 barrels per minute. Although that seems like an impossibly high amount, the uses for petroleum have expanded to almost every area of life. Petroleum makes our lives easy in many ways. In many countries, including the U.S., the oil industry provides millions of jobs, from surveyors and platform workers to geologists and engineers. The United States consumes more oil than any other country. In 2011, the U.S. consumed more than 19 million barrels of oil every day. This is more than all of the oil consumed in Latin America, 8.5 million, and Eastern Europe and Eurasia, 5.5 million combined. Petroleum is an ingredient in thousands of everyday items. The gasoline that we depend on for transportation to school, work, or vacation comes from crude oil. A barrel of petroleum produces about 72 liters, 19 gallons, of gasoline, and is used by people all over the world to power cars, boats, jets, and scooters. Diesel-powered generators are used in many remote homes, schools, and hospitals. During emergencies, when the power grid is interrupted, diesel generators save lives by providing electricity to hospitals, apartment complexes, schools, and other buildings that would otherwise be cold and in the dark. Petroleum is also used in liquid products such as nail polish, rubbing alcohol, and ammonia. Petroleum is found in recreational items as diverse as surfboards, footballs and basketballs, bicycle tires, golf bags, tents, cameras, and fishing lures. Petroleum is also contained in more essential items such as artificial limbs, water pipes, and vitamin capsules. In our homes, we are surrounded by and depend on products that contain petroleum. House paint, trash bags, roofing, shoes, telephones, hair curlers, and even crayons contain refined petroleum. There are major disadvantages to extracting fossil fuels, and extracting petroleum is a controversial industry. Carbon, an essential element on Earth, makes up about 85% of the hydrocarbons in petroleum. Carbon constantly cycles between the water, land, and atmosphere. Carbon is absorbed by plants and is part of every living organism as it moves through the food web. Carbon is naturally released through volcanoes, soil erosion, and evaporation. When carbon is released into the atmosphere, it absorbs and retains heat, regulating Earth's temperature and making our planet habitable. Not all of the carbon on Earth is involved in the carbon cycle above ground. Vast quantities of it are sequestered, or stored, underground, in the form of fossil fuels and in the soil. This sequestered carbon is necessary because it keeps Earth's carbon budget balanced. However, that budget is falling out of balance. Since the Industrial Revolution, fossil fuels have been aggressively extracted and burned for energy or fuel. This releases the carbon that has been sequestered underground, and upsets the carbon budget. This affects the quality of our air, water, and overall climate. The taiga, for example, sequesters vast amounts of carbon in its trees and below the forest floor. Drilling for natural resources not only releases the carbon stored in the fossil fuels, but also the carbon stored in the forest itself. Combusting gasoline, which is made from petroleum, is particularly harmful to the environment. Every 3.8 liters, 1 gallon, of ethanol-free gas that is combusted in a car's engine releases about 9 kilograms, 20 pounds, of carbon dioxide into the environment. Gasoline infused with 10% ethanol releases about 8 kilograms, 17 pounds. Diesel fuel releases about 10 kilograms, 22 pounds, of carbon dioxide, while biodiesel diesel with 10% biofuel emits about 9 kilograms, 20 pounds. Gasoline and diesel also directly pollute the atmosphere. They emit toxic compounds and particulates, including formaldehyde and benzene. Oil is a major component of modern civilization. In developing countries, access to affordable energy can empower citizens and lead to higher quality of life. Petroleum provides transportation fuel, is a part of many chemicals and medicines, and is used to make crucial items such as heart valves, contact lenses, and bandages. Oil reserves attract outside investment and are important for improving countries' overall economy. However, a developing country's access to oil can also affect the power relationship between a government and its people. In some countries, having access to oil can lead government to be less democratic, a situation nicknamed a petro-dictatorship. Russia, Nigeria, and Iran have all been accused of having petro-authoritarian regimes. Oil is a non-renewable resource, and the world's oil reserves will not always be enough to provide for the world's demand for petroleum. Peak oil is the point when the oil industry is extracting the maximum possible amount of petroleum. After peak oil, petroleum production will only decrease. After peak oil, there will be a decline in production and a rise in costs for the remaining supply. Measuring peak oil uses the reserves to production ratio, RPR. This ratio compares the amount of proven oil reserves to the current extraction rate. The reserves to production ratio is expressed in years. The RPR is different for every oil rig and every oil producing area. Oil producing regions that are also major consumers of oil have a lower RPR than oil producers with low levels of consumption. According to one industry report, the United States has an RPR of about 9 years. The oil-rich, developing nation of Iran, which has a much lower consumption rate, has an RPR of more than 80 years. It is impossible to know the precise year for peak oil. Some geologists argue it has already passed, while others maintain that extraction technology will delay peak oil for decades. Many geologists estimate that peak oil might be reached within 20 years. Individuals, industries, and organizations are increasingly concerned with peak oil and environmental consequences of petroleum extraction. Alternatives to oil are being developed in some areas, and governments and organizations are encouraging citizens to change their habits so we do not rely so heavily on oil. Bioasphalts, for example, are asphalts made from renewable sources such as molasses, sugar, corn, potato starch, or even byproducts of oil processes. Although they provide a non-toxic alternative to bitumen, bioasphalts require huge crop yields, which puts a strain on the agricultural industry. Algae is also a potentially enormous source of energy. Algae oil, so-called green crude, can be converted into a biofuel. Algae grows extremely quickly and takes up a fraction of the space used by other biofuel feedstocks. About 38,849 square kilometers, 15,000 square miles, of algae, less than half the size of the U.S. state of Maine, would provide enough biofuel to replace all of the U.S.'s petroleum needs. Algae absorbs pollution, releases oxygen, and does not require freshwater. The country of Sweden has made it a priority to drastically reduce its dependence on oil and other fossil fuel energy by 2020. Experts in agriculture, science, industry, forestry, and energy have come together to develop sources of sustainable energy, including geothermal heat pumps, wind farms, wave and solar energy, and domestic biofuel for hybrid vehicles. Changes in society's habits, such as increasing public transportation and video conferencing for businesses, are also part of the plan to decrease oil use. Articles and profiles. OPEC. About OPEC. U.S. Energy Information Administration. Petroleum and other liquids. U.S. Department of Energy. Fossil energy, petroleum reserves. Petroleum, or crude oil, is a fossil fuel and non-renewable source of energy.